When two variables are directly related to each other, it means that when one gets bigger, the other also gets bigger. In a word problem, the phrases that you'll see when this is the case are that y varies directly with x, or that y is directly proportional to x. And when you see one of these phrases, they translate into a math equation. And in this equation, you can see that as the values of x get larger, the values of y will also get larger. This is a direct relationship. If two variables are inversely related to each other, that means that as one variable gets bigger, the other one gets smaller. In a word problem, you'll see the phrase that y varies inversely with x, or that y is inversely proportional to x. And when you see one of those phrases, they translate into a math equation that looks like this. And from here you can see that if we plug values that are bigger and bigger and bigger into x, the output y values are going to get smaller and smaller and smaller. So this is an inverse relationship. Both of these variation equations contain a value k, and this k is called the constant of proportionality, or some may refer to it as the variation constant. This constant of proportionality is going to help us to determine how fast this is occurring. So in the direct relationship, we can see that, yes, if I plug in bigger x values, the y value is going to get bigger, and k just tells me at what rate. So let's look at a few simple examples just to outline the process that's going to be used. In part A, we see that y varies inversely with x. And as we said a moment ago, this phrase translates into the math equation where y is equal to k divided by x. Let's make note of the fact that the variation constant is going to be located in the top of the fraction, and the variable that y is inversely related to is in the bottom of the fraction. So this first phrase translates into what we'll refer to as a template equation that we're using based on the fact that this was inverse variation. In step 2, we're asked to find initial conditions and use them to figure out what our variation constant is. So back down here in the example, we can see that we're given some initial conditions here. If y is 9 when x is 4, these are the initial conditions that can be used to find that variation constant. So we'll plug in 9 for y, k is the value that we're trying to solve for, and we plug in x is equal to 4. Now k is the only variable that remains in the equation, and we can simply multiply both sides by our LCD, which is 4. So 4 multiplied on the left-hand side is 36, and 4 multiplied on the right-hand side here is just going to be k. So we just use the initial conditions to figure out what the value of k must be. So now that we've found the value of k, we're going to replace the k in the template equation with this new found value of k. So we're going to plug 36 in for k back into the original template equation. So our variation equation now becomes y is equal to 36 over x. And now not only do we know that as we plug in larger values of x, the y values are going to get smaller, but our value of k is equal to 36 now tells us a little bit about the rate at which that's occurring. So the last thing that we're going to do is to use the completed variation equation to answer any remaining questions. The remaining question here is that we want to find y when x is equal to 2. So using our completed variation equation, we're going to plug in x is equal to 2 and solve for y. So we say y is equal to 36 divided by, plugging 2 in for x, we get that y is equal to 18, and that's going to be the answer to our final question. Let's do this one more time in part B. We're given that p varies directly with q, and this phrase translates into p is equal to k times q. A direct relationship between variables means that as one gets bigger, the other one also gets bigger. The first thing that we're going to do is use the initial conditions to figure out the value of k, and these are our initial conditions. We're told that when q is equal to 2, p is going to equal 12. So let's plug in 12 for p. We're trying to solve for k here, and we're going to plug in 2 for q. Now k is the only variable that remains in this equation, so to solve for it, we're simply going to divide both sides by 2 to get that k is equal to 6. So now that we've found the value of k, we're going to plug that back into the initial template equation so that we can more clearly describe how p and q are related. Yes, as q gets bigger, p also gets bigger, but the value that we're multiplying the q by is going to be 6. So now that the relationship between p and q is more clear, we'll use the updated variation equation to answer any remaining questions. So this is the remaining question here at the end. We're asked to figure out what is p when q is equal to 5. Well, we know our k value is 6, so we're going to plug in 5 for q to see that p is equal to 30.